All right, folks, today the goal is to get really comfortable with factoring. When we see a trinomial that looks like ax squared bxc, basically this thing tells us this is a quadratic equation. We've heard that word before. Okay, power of 2. But we're seeing a number in front and a number in the back that aren't perfect squares like we saw with perfect square trinomials. And just making sure we understand what to do when there's this a involved. So first thing, I am giving you an example here. So we're talking about this trinomial, and it factors into this. Okay, so first we're going to convince that this is actually true. These are equal. And we're doing that by taking our two binomials and foiling them. Okay, so remember, first times first will give us 3x squared, which is so far so good. Then outside plus 6x. Inside plus 2x, and last plus 4. And then we have some like terms in the middle here. We've got 3x squared plus 8x plus 4, and it matches exactly to what we started with. So we've got to get from this version to our factored version, our two sets of parentheses here, without knowing what numbers go in ahead of time. Okay, so what we're going to focus on is the patterns we see. Here's the idea. The first and the first had to match with the first term from the trinomial. Okay, that part of the foiling directly related to our first part of our trinomial. Okay, similarly, the last and the last here has to directly relate to our last term of our trinomial. The middle terms in this part, the 6 and the 2, go with that middle term. And these are the hardest part about this. Okay, but what we're going to do is talk about a strategy that lets us find those numbers and find how to put this stuff together in a way to get the right answer every single time without just guessing and checking. Okay, so here's what I mean. I know if I have to multiply to 3x squared, I have to use a 3 and a 1 because those are the only factors of 3. Okay, then I can split up x and x, but when I've got a 4 here, there are multiple factors of 4. I could use a 1 and a 4, or I could use a 2 and a 2, and we'd have to guess which one goes where. So it could be 1, 4, 4, 1, or 2 and 2. Okay, to take the guesswork out of it, that's the goal of today. I'm going to show you a strategy that gets us the right answer every time, no guesswork. So here's what it's going to look like. Our first step always is look for a GCF. This one is the same example, and I know there's not a GCF here. Okay, so we don't have to worry. I'm just showing you how the process works based on what we just talked about with this 3x squared plus 8x plus 4. Okay, so your first step is going to be taking the first number times the last number. That in our formatting is a times c. Okay, so that's step 1. A lot of times I'm going to call this frowny face factoring. Okay, 1, because it's a little bit tougher than other factoring, but also it makes a frowny face as you do this path from A to C that we're multiplying. Okay, so step 1 is just multiply those together. And then we're looking at those factors of 12. What I'm going to recommend is you draw your diamond here. The 12 is our product, and we're trying to get to the factors that add to 8, that middle term. Okay, so these are where the numbers come from in what we've practiced all chapter long. Okay, then we're figuring out the ones that work. So I've already listed them here. The ones that work are your 2 and your 6. Okay, and we'll worry about the sign after the fact, so I just want you to worry about the 2 and the 6 here. Because they're positive 12, that's why these all ended up being positive. Okay, but we'll practice that as we see different examples. So then what we're going to do is, because we know that the equivalent form had 2 sets of parentheses, we're going to start there. In fact, we're going to put the x in and the x in automatically because that's going to take care of the x squared. Okay, the only problem is when we multiply these, I told you that first times first has to relate to this number, and x times x isn't 3x squared, it's just 3, or it's just x squared. That 3 is missing, it's the problem. Okay, so these numbers, the 2 and the 6, are going to go in the blanks here, but because of this, we have a problem. So it says divide the factors by a, that's our a value, that's our number in front. Go ahead and write your a equals here. We're going to divide off the problem. Okay, so put a divided by 3, divided by 3. Okay, but I've been telling you that fractions are not allowed in factored form, so we have to get rid of them. Sometimes getting rid of them is as simple as just reducing. So if you look at the right, 6 divided by 3 is 2. It's already gone. So this x comes down, the plus comes down. But sometimes it doesn't reduce. I've got 2 over 3 here. That doesn't simplify. We're going to get rid of it by thinking about this as 2 divided by 3. To get rid of divided by 3, you just have to times by 3. And we're going to only do that on the piece that has the problem. So this would be 3 times x is 3x. 3 times 2/3, the 3 and the 3 cancel, where it's just plus 2. And this is the factored form from the previous page. Okay? No guesswork. We're going to follow these steps every single time. Okay, so let's practice. First step is we're going to look for a GCF always. Write this at the top here. GCF is first step always. So here, 2, 13, 6, there's nothing in common. Okay, so we're done with that part. Next, we're doing the frowny face factoring. We're taking this times this and putting it in our diamond. 2 times 6 is 12, and then that other number goes on the bottom. So we're looking at the factors of 12 that add to be 13. Okay, don't forget about 1 and the number itself. That's 1 and 12. Okay, then step 2 is you're going to set 2 sets of parentheses open, and you're going to put your variable in both spots. Our variable is x, so we're putting 1 in each. Okay, but here's the deal. It's supposed to be x times x gets us this number, but it says 2x squared, so we have to just divide by that number. We'll plop our plus 1, and we'll plop our plus 12. We just have to divide them by this a value. Okay, so I want you to just write this note here. Divide by a, and ours was 2. So put a 2 there and a 2 there. And now we simplify our fractions and eliminate them if we can't. So this first part, I don't have a way to simplify 1 over 2. So this says divided by 2. We'll times by 2 to get rid of it. So my first set would look like 2x. 2 times 1/2 is 1. Done with that part. Over here, 12 over 2 is 6, so x plus 6. And this is what I want you to do after you've done that. We are always going to check our answer. We didn't worry about that on the first one because we knew what our answer was. We just compared it. We're going to check by visually foiling. We're not going to actually write it down because this will be our answer as long as it checks. Okay, so in your mind, you're taking first times first, 2x times x, it checks. Okay, then you're doing the last terms. Okay, so now we're looking at 1 and 6. So 1 times 6 is 6, that checks. And then we do our FOIL, outside and inside, we'll check your middle term. So this is 12x, 1x, those combine to be 13. This is our answer, put a box around it. Okay, I would love it if we get a point where we don't have to draw in those arcs because I want your factored form to look real nice here, just 2 sets of parentheses smushed together. And that's it. Alright, this one, first step GCF again. 3m squared, 2m, and minus 5. There is not one. Okay, so we're making the frowny face. 3 times a negative 5 is negative 15. Signs do matter. I said we would talk about those signs as we see them. Here's the first one. Then our positive 2 goes on the bottom. When we are multiplying to be a negative, our signs have to be 1 positive, 1 negative. Okay, so really that means we're looking for a difference of 2 with our factors. So 1 and 15 doesn't have a difference of 2. 2 doesn't go in evenly. 3 goes in 5 times. They're 2 apart. That one works. Okay, so I know it has to be 3 and 5. And I need a positive 2. So that means this would have to be negative. 5 minus 3 is 2. Okay? And now that we have that, we're able to follow the same process as the last one. M and m, since that's our variable this time, we're writing down those numbers, minus 3 plus 5, but right now it says m times m is 3m squared, and that's not true. So we just have to divide off that number on both of these. always divide by this. Okay? Now we simplify. First one, 3 over 3 is just 1. Over here, it says divided by 3. We got to times by 3. So 3m plus 5. And we check it always. Okay, so first times first, m times 3m is 3m squared. Okay, outside and inside go together. Plus 5 minus 3. Positive 5 minus 3 is 2. That was our factors. That's perfect. And then last times last gets you a negative 5. It works out. All right. Looking at the next one, GCF first. 7, 15, 2. There is not one. We're multiplying A times C, that frowny face from the first to the end. That number you get when you multiply goes on top. 7 times 2 is 14. And the number in the middle goes below. So factors of 14 that add to be negative 15. Remember, we haven't talked about this yet because we hadn't seen the negative before. But when you're multiplying to be a positive number, your signs have to match. Okay? So if your signs have to match, they have to be both positive or both negative. This says negative, so we have to have both negative. Okay? Then we want numbers that are factors of 14 and add to be 15. Okay, that's our 1 and our 14. Don't forget 1 in itself. Okay, it's most commonly missed 1. And then we're ready to plot them. Our variable this time is r, so put an r in both places. Then put your factors, the negative 1, negative 14. And this says r times r is 7r squared. Okay, we got to fix that 7. Alright, this first one doesn't reduce, so we just got to multiply that 7. It says divide, we times. 7r minus 1. Okay, those will always cancel. That number just comes down. This part reduces. 14 over 7 is 2. So this is just r minus 2, and we're checking it. Okay, 7r times r, 7r squared. Okay, and then we've got outside negative 14, inside negative 1. Negative 14 and negative 1 makes negative 15, so that checks. Negative 1 times a negative 2 is a positive 2, so that works out. Alright, I want you to pause the video and walk through your first 2 steps. You looked for the GCF, okay, and then you filled out your diamond. Okay, there was not a GCF here. So 3 times 2 gave us 6. And you should have had some trouble finding numbers here because the factors of 6 are 1 and 6 and 2 and 3. And neither of those can get you to 9. If you have a situation where you can't find the factors and you've listed them all, okay, because they may not be obvious, make sure you go through every single possibility. If you've gone through all the possibilities and nothing works, it's considered prime. Just like prime numbers have only 1 in itself as factors, okay, trinomials can be prime if they don't have factors other than 1 and itself. Okay, so this one is prime. Alright, next thing we're going to do is just add a step. We're going to solve, which means we follow the same process we've been doing, and then we use our zero product property to actually solve for our variable. Okay, so step 1 is still GCF. Okay, so here, here, and here, there's nothing in common. So we're taking our frowny face, and that's a negative 6. We're trying to add to negative 5, and we're looking for factors. I'm going to have you pause the video every time we do this, because the hardest thing when we're going through here is figuring out what these factors are. We've been practicing, but we need more practice. So pause the video, go find those, and you can hit play once you got them. Okay, so here, this should have been a negative 6 and a positive 1, because remember, when this is negative, you have to have opposite signs. Okay, so we're looking for a difference of 5, and that works out. We want the negative to stay. So then we've got x minus 6, x plus 1. This time I want you to drag an equal 0 for me, okay, because it's an equation that's going to come along in every single step. And then x times x doesn't give us 2x squared, so we got to fix that. Just divide off that 2. Okay, here This says x minus 3. It just simplifies. And then on this one, we got to multiply that 2 to fix it. So that would look like 2x plus 1 equals 0. All right? From there, this is review from the last few times we've been practicing this. Each piece gets set equal to 0 to solve. X minus 3 could be 0, or 2x plus 1 could be 0, and we solve each of them separately. So we're adding 3 over here to get positive 3, and we're subtracting 1 and dividing by 2 on this one to get negative 1/2. Solutions go in set brackets, and we're all done. Okay. Next up is the same process. GCF is non-existent here, and we're taking A times C. Okay, I want you to try this, and I don't want you to stop after the factors. I want you to try this all the way through to your factored form, and I want you to check that it foils back to the original, just like we had been practicing, and then we'll talk about solving it together. Okay, pause the video and take care of that for me, please. This was 18 and 9. Okay, so our factors are 6 and 3, both positive. We're taking n plus 6 and n plus 3. Don't forget your equals 0. Add it on there if you missed it. But n times n does not get you 9n squared, so we have to divide by that 9, divide by that 9. This one looks a little different, right? Okay, so when we simplified this, okay, we've reduced before, but we've only reduced where a whole number came out. This is super important. Okay, so this one, really important, you're always reducing first. Okay, make yourself a note of that. This would just be n plus 2 over 3. This one would be n plus 1 over 3. But I still have fractions, meaning I still have problems. So I have to fix it now. Okay, so we're going to multiply this one by 3. And that's 3n plus 2. This one also gets multiplied by 3. They don't have to be the same, by the way. That was just luck here. And this would be 3n plus 1. If you didn't reduce first and you checked it like I told you to, okay, I said pause after you factored it and check it by foiling, okay, you probably didn't get it to match, okay? So reducing first makes sure that it actually matches when we check it. So let's do that together with these numbers. 3n and 3n makes 9n squared, so that one's good. Okay, 2 and 1, when we're multiplying them, give us 2. So that's good. Last thing, we just got to check our FOIL. Okay, so outside is 3n, inside is 6n. 3 and 6 makes 9. It works. Okay, now we're ready to solve. So each piece goes equal to 0, 3n plus 2, and 3n plus 1. And we solve just trying to get that variable by itself. So 3n equals negative 2. Divide by 3. First one is negative 2/3. Over here, subtracting 1, dividing by 3. So we've got a negative 1/3. Okay. Now what I want you to do is just pay attention to what's happening here. This was our factored form, and we put some 3's on there to fix it, but this was our factored form, and these are our solutions. Okay, before we fixed our fractions. Okay, same thing here. This was our factored form before we fixed stuff, and here were our solutions. If you notice it, and it's honestly easier to notice here than over here, this 2/3 showed up positive, ours showed up negative. This was positive, that was negative. Same thing happened here. Positive 1/2 switched to negative, and this was really a negative 3, right, because 6 over 2, it went to positive 3. It's always going to do that. So we have to fix it. I'm telling you, fixing it, because fractions are not allowed, that lets us check ourselves to make sure we factored correctly. That's something that's graded. But then this, your solutions, you can skip these steps to solve if you just take the opposite of what you had in that previous step. Okay, I'm grading these boxed areas, factored form equal to 0, and your solutions. Okay, the steps in between, if you get used to seeing those patterns, you don't have to have all of them. Okay, let's practice on this next one. You'll notice these look a little bit different than the last ones. It's just because they didn't have them equal 0. We do want, when we're solving equations, equal 0 to happen. So let's subtract this 15 over and simplify. Okay, we've got 4a squared minus 18a, and this would be negative 10 equals 0. Okay, now we're at a point where we're looking for a GCF. And this is the first time we've actually seen one. Okay, so 2 goes into every term here. We're going to factor it out and write what's left. Okay, so we're thinking 2 times what gets us to 4a squared? That would be 2a squared. 2 times what gets us to negative 18? We'd need a negative 9. A comes down. And 2 times what gets us to negative 10? That's negative 5. Okay, but in terms of factoring, we're not done until the squareds go away for these ones, okay, unless it's prime. So we're going to try looking at this part and factoring it as well. So here's how I want you to do this. This 2 is going to come out to the side, and I want you to put a bracket here because we're going to think about this just like the last ones where we have a couple steps involved. So we're taking our 2 times our negative 5, and that gives you negative 10, and we're looking at this negative 9 in the middle. So pause the video, find those factors, then you can hit play. This should have been negative 10, positive 1, and we're bringing down our parentheses. Just like normal, they're just inside brackets now. Okay, we want a, and we want our negative 10 and our positive 1. We just have to divide by this. I had you put this 2 out here because this is the GCF. It was just a coincidence that this number here matched it. That won't happen all the time. Okay, so this 2 we still have to divide by because we're saying a times a should equal 2a squared. And it doesn't right now, so we'll fix it. Okay, 2 comes down again, and we simplify. Okay, keep your bracket until you're done simplifying stuff. So here, this was just a minus 5, no problem. But over here, we have to multiply by 2 to get rid of that fraction. So this would be 2a plus 1. And now, that 2 can stay out here if you want, but a lot of times I'll write it just with parentheses in the front with our regular factored form. Okay, this part should check with this part. Let's do that real quick. A times 2a is supposed to match this first term, and it does. Okay, then our last and last, negative 5 and positive 1 multiplies to negative 5, so that's good. And then outsides and insides are our middle term. So 1 and negative 10, negative 9, that works out. So there's our factored form. It checks, and then we solve. Each piece goes equal to 0. So 2 equals 0, that's false, so it doesn't count. A minus 5 equals 0. We add that 5 over. And 2a plus 1 equals 0, and we solve that one. Subtract the 1 first, divide by 2. So the solutions are just the 5 and the negative 1/2. And remember, you can use opposite of this to save a little bit of that work. Alright, let's try this one. We're adding the 48 over to get equal 0. This time it has nowhere to go, so you just put it to the side. And again, GCF is next. Okay, so GCF on this one is 4. 4 times 2m squared. 4 times negative 11m. And 4 times 12 to get us back to the original. Okay, I want you to write this 4, write a bracket, and I want you to go factor this into its fractions. Pause the video, take care of it for me. Should have had 24, negative 11. That means negative 3 and negative 8. Signs have to match, and we need negative. And this would have looked like m minus 3 over 2 from this number. I told you that was just a coincidence over there. Okay, and then on this one, m minus 8 over 2. Okay, we're writing the 4, and let's fix it together here. This first one didn't reduce, so that 2, we got to multiply through. 2m minus 3. Okay, if you're not convinced that 2 times the negative 3 halves is actually negative 3, type it in your calculator. Take 2 times negative 3 over 2. It'll tell you what it is. Okay, there's nothing wrong with that. Over here, 8 divided by 2 is 4. So m minus 4. And we're going to check it before we move on. Remember, this is what we're trying to say these two equals. So 2m times m is 2m squared. That works. Negative 3 times negative 4, positive 12. That works. And then outsides and insides are what go with your middle term. Negative 8, negative 3. They should match this, and they should match the middle. We're good to go. Okay, pause the video. Go get the solutions now. These should have been 3 halves and 4. Okay, again, opposite of these, or we're setting them each equal to 0. So I would add 3, that's positive 3. Divide by 2, it goes to the denominator. Add 4, positive 4, and we're done. These are the only 2 items here that I'm grading. Okay, those are the ones that you need to see. Okay, we're going to talk about the factoring cheat sheet and making sure we understand the steps to factoring and the steps that we need to be thinking through as we go. So step 1 is GCF. Okay, we're looking for a common factor. Okay, after that, we're going to classify our different things we're factoring in terms of quadratics as difference of squares with 2 terms, okay, or lots of different options when we have 3 terms. Okay, so let's split this up. 2 terms, 3 terms. Okay, 2 terms, the only option is difference of squares. So that looks like a squared minus b squared. Both of these are perfect squares. And if it's a difference of squares, we're going to have these things happen just like what we were talking about. But with our pattern, if it's a square, it's always going to factor into the square roots. So the square root of a squared is a. The square root of b squared is b. And then we're multiplying to get a negative number, so 1 positive, 1 negative. And that's why you had those opposite signs canceling out that middle term. This is positive ab and negative ab that cancel out, so the middle term's gone. Okay, 3 terms, there's a couple different options. Okay, the first option is we could have a perfect square trinomial. So that's the a squared plus 2ab, and this could be plus or minus, and then plus b squared. Okay, that factors in. I'm going to have you write it this way, again, to square roots. This one's a and a, square root b and b, but what's different here is we're multiplying to be a positive number. So our signs have to be matching. They have to be both positive or both negative. And that's why we learned that we could write it as this binomial being squared. It matches directly with what we've been doing. The only thing with these 2 items is if they're perfect squares, we don't have to guess and check about which factors go where. It's always the square roots. Okay, so that's nice. And then the second part is when a equals 1. Okay, we'll get to that. But the third part is what we talked about today, and that's when a isn't 1. When there's a number in front, a being your ax squared, that number in front, the part of the a times c that we were working with, if that's a number other than 1, and that's all we've seen today, it's our frowny face factoring, and we follow some steps. Okay, so step 1, we have to recognize the pattern. So it's ax squared plus bx plus c, and our first step is take a times c. So that would go in our diamond here, and then we're looking for the factors of our middle term, so that would be our b, and then we just fill them in. So we know that this, since it's x, would be x and x. We know that there's going to be some number here. It could be plus or it could be minus, but either way, we're going to divide by whatever this a value is. Okay, so we've got over A over A. This is some number from here that you go find. And again, I'm not going to put a sign in here because it could be positive or it could be negative depending on what happens. Okay, so something goes in here, plus or minus. And that's it. Okay, so we're going to follow that process on these last two examples, making sure we know how to do these things no matter what kind of pattern we're seeing. So first step is GCF. And here, 1, 10, and 9, there's not a common factor. Okay, so because there's not a common factor, we're looking for, from our thing, we're trying to see if it has 2 terms or 3 terms, and it does have 3. Okay, we're going to always check perfect square trinomial first, and then we'll follow that process that we talked about if not. Okay, so x squared is a perfect square. 9 is a perfect square, so we're going to check it. X and 3. This only works if when you multiply those and double it, you get to this. So this would be 3x. Is this doubled the same thing? And if we double 3x, it's 6x, so this is not a perfect square trinomial. Alright, so then we're doing what we did today. This is the first one we've seen where A is not a regular number. If it's not anything in front, it's just 1. So 1 times 9 is just 9, makes it a little bit easier. And we're looking for the factors of 9 that add to be 10. That, of course, is 1 in itself. And we're following the same process. We've got x. So x and x equal to 0. And we're putting these in, plus 1 and plus 9. Okay, here's what's a little bit different, and we're going to go over this a little bit more next time, but we've been dividing by A because we said x times x should be equal to that first term. And for the first time, it actually is. We only have to divide by A if we have to fix the problem in front. We know dividing by 1 keeps it 1, keeps it 9, so that step we actually get to skip for these ones. So when A is 1, okay, it's still frowny face factoring, but you don't have to divide by anything since that number is just 1. So then, we're ready to solve. X plus 1 equals 0, x plus 9 equals 0, subtracting 1, subtracting 9, or they just flip-flop. We've got negative 1, negative 9, and we're done. Okay, on number 15, same process, GCF first. Okay, 81 and 4. There isn't anything in common with 81 and 4, so we are looking how many terms this has. Okay, 2 terms or 3 terms, and it does have 2 terms, so we're just checking, is it a difference of squares? Okay, we're going to do those square roots just like last time. Square root of this is 9x. Square root of this is 2. Alright, with a difference of squares, there is no middle term, so as long as those have perfect square roots, and that's minus, it is a difference of square. Okay, so go ahead to parentheses equal to 0. And how this is different is we're going to take these numbers and put them in. With our factoring, first and first has to get this number, so 9x and 9x go there. And the last and the last go with that negative 4, so we've got 2 and our 2. And these things were different signs because we're multiplying to be a negative. And we said that has to be opposite. Okay? Now we're setting them equal to 0. And solving. Subtracting 2. Again, show as many steps on this as you need to make sure you get the right answer. So this first one is negative 2/9. And over here, hopefully you recognize that these are just opposites, so this will be a positive 2/9. But if you need to write it out, please do. And then dividing that 9 to finish up. And that's it. Okay, we're going to practice more in the coming days, more types of factoring. Okay, but if you have any difficulty on your homework while you're working through it, please come see me immediately. Okay, don't wait until the review day to get help with this because it does build and you just need to practice, practice, practice for these.